welcome back. In the subsection 2 of learning algebra, we are now going to look at the linear algebra. In our previous video, we give an example with respect to the introduction to algebra, and we look at why algebra is important. In this video, we are going to define what is a linear algebra and what does linear algebra normally do to science and engineering. If you want to understand fully the linear algebra in this section, you can watch this video series till the end, and I believe at the end of the video you can fully understand why do we need linear algebra in engineering and science. So linear algebra is defined as a branch in mathematics. When you learn mathematics, you definitely going to learn what is a linear algebra. And linear algebra, it mostly focus on the linear equation, the matrices, the vector space, and the linear transformation. And basically, it is a tool for solving systems of equation. And this system of equation, as I have mentioned over and over, every system is represented mathematically by an equation. And this linear algebra is now a tool for solving those equations. Without algebra, we cannot solve the mathematics that is involved in the system. And it analyzes the geometrical structure in multiple dimensions. And I will go through each of these type of mathematics that the linear algebra mostly focus. The first one is nothing but the linear equation. It is now defined as the equation that describes a straight line. We all know what is a straight line. Imagine you have a graph of a DC voltage, and if you have the amplitude of the voltage given as 3 volts, now we can describe the voltage as a straight line. And to describe this straight line, we normally use the linear equation. Another example like what we did in terms of the current and the voltage, and we said that the slope represents the value of the resistance, and this slope is also a straight line. In order to understand this straight line and analyze those particular straight line, we normally use the linear equation in algebra. Therefore, it is important for you to learn what is algebra, especially the linear equation. And secondly, it talks about the matrices. So what is a matrices? And the matrices talks about the rectangular array of numbers used to represent a linear transformation. What do we know about the arrays of a number? Meaning, you can have a number, for example, x1, x12, x13, x14, and x1n, and you can have x21, x22, x23, x24, and x2n all the way, and you can have this portion represent the array or the matrices, and this portion can represent a vector if we have theta 1, theta 2, and so on. So if we want to find y, then we can use the matrices to solve for the unknown. And this type of matrices is popular in, example, the control system. We want to learn adaptive control, where Some of the application can be the self-driving vehicle, and drone stability, and in applications such as the power electronics, you will learn the buck and the boost converter, where the buck and boost converter can be represented by a state variable, and those state variable can be computed using matrices. Therefore, if you want to further in the field of engineering, most of the system can be represented using matrices, and you have to know how to solve using matrices. And the linear algebra is also a tool that can help you to find the unknown in this type of system that we discussed, such as in adaptive control, power electronics, and many control scheme used in engineering. Thirdly, we have the vector space. So what is a vector space? And it can be defined as an object with magnitude and the direction. Example, if you have a vehicle that is traveling, and this particular vehicle can be seen as an object, and it has parameters such as the weight, and when traveling it has a speed, and we have the direction. When we want to compute a vector compared to a scalar quantity, we normally consider a vector because it is more precise, because it has a term which is direction. Because if we talk about the speed, it is okay. We know the car is traveling at a certain speed, but without a direction, we cannot fully understand where the vehicle is traveling. So in most cases, it is regarded that we have to use a vector quantity to represent the magnitude of the speed and the direction of the vehicle. So when describing the speed, we can say it is the velocity which is equals to displacement over the time. And when using a linear algebra expression, we can say the velocity is equals to displacement over time. And when we talk about the speed, we say the distance over the time, and speed is equals to the distance over the time. The only difference between a vector, any vector variable will have a bar at the top, which normally represent that we are now having a direction in comparison to the magnitude. So we can see that the speed is a scalar quantity, meaning no direction is added. However, when we look at the velocity, it is a vector. Why? Because there is direction included. And it is very important to differentiate between knowing the vector and the scalar quantity. And the linear algebra provide us with an effective tools to analyze such system. So when the object is traveling, it can represent a real-time scenario. And in order to analyze the speed of the vehicle, a speed of an aeroplane, and many other systems, we normally consider in terms of the vector space, because the unknown is the vector itself. And the final one, which is the linear transformation. So we have linear equation, and now we have the term transformation. So it is defined as, and it is a function between two vector space that preserve the operation of a vector and a scalar. So linear transformation normally deals with a function that govern the linear equation, matrices, and vector space. When we want to transform a vector such that for a two-dimensional vector space if we have x and if we have y, and if we have a point which is given in this dot here, and operations such as a rotation. If we want to rotate this particular point having x and y, we can apply linear transformation, so it will rotate to this point. That means we are rotating between the vertical plane, and if this is 10, then when we rotate it will become minus 10. So this can be one application of linear transformation, and this type of transformation can be mostly used in the computer graphics and the computer animation course, where most of the application of how a vector is projected onto a screen will mostly be affected due to the linear transformation. So we have operations such as rotation, scaling, and translation. So most of these operations, they normally use a linear transformation. That means we are dealing with a 2D object. To motivate you, we can say if you learn linear algebra, then it is mostly and widely used in engineering. If you want to study engineering, it is a must that you have to learn linear algebra and physics. If you want to study physics, then this linear algebra is important, and the computer science, where I have explained computer animation, you will mostly need to apply linear algebra in solving the problem, and economics and data science. So those are some of the fields in which you will come across most of the problem solving using a tool called the linear algebra. So if you want to know more, we will now dive deep into understanding the linear equation as a first topic in linear algebra. And now the linear equation, which we described earlier as the equation that describes a straight line. And there are 3 steps in linear algebra. The first step is known as a one-step equation. If you come across an equation, as an example, if you have the equation x plus 5 is equals to 12, then in a one-step equation, it requires only one operation. And this operation can be subtract 5 in both sides. So you have x plus 5 minus 5 equals to 12 minus the 5. Now you should have x is equals to 7. So we have only one operation done in this linear equation. So this is nothing but the linear equation, where it has a constant and a variable. The second step is known as the two-step equation. Now, in a two-step equation, we can simply say we have two operations performed to this linear equation. In example, if we have 3x minus 4 is equals to 11. Now, the first operation is to add 4 to both sides of the equation. So we can have 3x minus 4 plus 4 equals to 11 plus 4. Now we have 3x is equals to 15. So this is the first step. Now the second step, we have 3x is equals to 15. We now divide 3 in both sides. So we should have x is equals to 5. That is, when we divide 3 in both sides, we now have x is equals to 5. And this is known as a two-step equation. And thirdly, we have a multi-step equation. So with multi-step, you can also define it as having multiple operation. That means more than one operation can be done to a system. Equation example, if we have 2x minus 3 plus 4 is equals to 10, first you want to do is minus 4 in both sides. So you should have 2x minus 3 is equals to 6. Now what do? We normally multiply the bracket. So we can have 2x minus 6 is equals to 6. So we can add 6 to both sides. So we can have 2x is equals to 12. And now we can divide 2 in both sides. We should have x is equals to 6. So this type of equation can be regarded as a multi-step equation. Just for your reference, it is important when you look at the equation, you can differentiate between the type of equation the linear algebra normally comes under, such as one-step, maybe two-step, and multi-step equation. But the important thing about learning the linear algebra is how you can solve the problem. And if you have a mathematical background, you can be able to solve linear equation without considering those steps. You can simply perform the transposing and operation on both sides of the equation. And from all this equation, we can see that a linear equation mostly used in algebra to describe a relationship with constant rate of change. So when you are working on a system where the rate of change is constant, then you know that definitely you are going to use a linear equation to analyze this particular system. And this linear equation can be shown graphically. We have seen some graph in our first video about the linear equation, and I will also give you another equation which is similar but with an added example. The mostly used graph is known as y is equals to mx plus c, and this represents the slope of a straight line. So when you look at the term straight line, it means the system is constant or it is linear. So the term linear, constant are relating to a system that comes under the linear equation. From this equation, we have the slope of the graph and the y-intercept. And the variable x and the y, they are a varying quantity, meaning this is a variable and the x is also a variable. And this equation now has two variables. So when we want to solve, we will base upon the changes in these two variables. And it is mostly in terms of a 2D space. When we say 2D space, we normally have the x and the y. And the x is nothing but the horizontal axis and the y is the vertical axis. Any line that is appear in this 2D space and it has a straight line, For example, this one, this one, this one, this one, this one, we can see that all of these lines, they represent a straight line. And those straight lines represent the change of the rate. And the change of rate is depend on the variable which is the x, and it can be found in the horizontal axis. And when we want to solve the equation for the straight line, we use the linear equation. And we normally use the expression. And this expression is the mathematical phrase as what we have discussed earlier. Because when you want to show a result of the system, you normally use a graphical representation. Because when an engineer or a technical person see the graph, it is easy for them to analyze the graph rather than you putting into a English phrase where it will be too long. Therefore, in substitution of this English phrase, they now use the mathematical phrase, which is known as the expression. And y equals mx plus c is now a mathematical phrase for describing a straight line. Some of the examples of the linear equation is the Ohm's law in electrical engineering. And for the Ohm's law, voltage equals current times resistance. We described this in our previous video. And we can have Kirchhoff current law and the Kirchhoff voltage law. Maybe in this video I will discuss Kirchhoff current law and Kirchhoff voltage law using the linear equation in algebra. And one additional example is in the linear motion, and it is mostly found in the physics. So we can relate the electrical with the physics, and because a linear motion mostly contain the change of the rate, and it can give us a clear idea of how we can use in terms of solving the linear equation. As an application for the Kirchhoff current law, this law states that the total current entering a circuit or a junction must be equal to the total current leaving the junction. So that means that the total current which enter must be equals to the total current leaving a junction. Imagine we have a junction and we have current entering this junction and the current leaving the junction. So we can say I1, I2, and the I3. And given that if we now measure using a multimeter to measure I2 and I3, therefore the equation can state that I1 plus I2, which is equals to the sum of current enter, and the I3 is equals to the sum of the current leaving this junction. And since if we measure and if we have 3 milliamps going into the junction, and when we measure the output we have, let's say, 5 milliamps, and this can also be represented in a figure such that if we have the I1 and I2, which is now the current source, and we have another voltage source which is now our I3. And from this equation we can see that the I1 plus I2, which is equals to I3. When substituting these values, we know that the I1 is unknown plus 3 milliamps is equals to 5 milliamps. Now we can transpose by saying I1 is equals to 5 milliamps minus 3 milliamps. When we minus 3 in both sides, Now we have I1 which is equals to 2 milliamps. When we are to plot such graph graphically, if we are to analyze using a graph, we can have time and the time. And we can say we have I1, I2, and which is equals to I3. And this is the time. And the time represents the rate of change. When we have I1, which is unknown, and we have I2, which is 3 milliamps from, let's say, 0 to 5 seconds, and we measure the output, which is 5 milliamps from 0 to 5 seconds. Then we all know that the I1 is now 2 milliamp. So we can plot 2 milliamp in this region. So this graphical representation is now referring to this equation. And the second diagram can be seen here. And this equation represents the rule for the Kirchhoff current law. Since it is a linear equation, that means the graph normally represents the straight line, like we have seen in the figure. And I1, I2, and I3, they are the variables. When changing the magnitude of the current in one of these variables, it will still affect the output. And it is seen as a linear equation. Another linear equation can be found under the Kirchhoff voltage law. So what is a Kirchhoff voltage law? The Kirchhoff voltage law states that the sum of all voltage in a closed loop circuit is equivalent to 0, and it is described as the sum of voltage in a closed loop must be equivalent to 0. That means if we have voltage source and voltage R1 and voltage R2, that means the voltage source plus the voltage R1 plus the voltage R2 must be equals to 0. And the voltage R1 and voltage R2 can be found such that we have the voltage source and we have resistor 1 and resistor 2. And when we connect a voltmeter V1 and V2, we will now get VR1 and VR2. Now if we have the voltage source is equals to 10 volts and VR1 is equals to 5 volts, now the VR2 is unknown. So we have to solve for VR2. By substituting these values into the equation, we can say 10 volts plus 5 volts plus VR2 is equals to 0. Now when we bring this to the other side, we can have 10 volts plus 5 volts is equals to minus VR2. And now we can have 15 volts which is equals to minus VR2. Therefore, when we divide minus in both sides, we have the VR2 is equivalent to minus 15 volts. When you have a voltage which is minus in this regard, the important thing for you to realize in a DC circuit is the polarity. And from the circuit, we can now be able to plot the polarity based on this linear equation. That means we are doing analysis for this particular circuit. Now, if we have the positive in this region and negative in this region, now this one becomes positive 10 volts. And from VR2, we can see that if we have minus here and positive here, we now will get positive 5 volts. And what will happen to VR2? VR2 will connect in such a way that this will become positive and this will become negative. Therefore, we should have 15 volts. Now when we add the voltage across a closed loop, the voltage total must be equals to the zero. Therefore, if we say from this equation, we have 10 plus 5 minus 15, it should give us 0. So with the change in the polarity is all about the change and the arrangement of the connection of the voltage source. Imagine you have a battery which is connected like this and connected like this. This one represent V1, this one represent VR1, and now we are connecting VR2 in this order. Now this represent this circuit here, and we have the positive and the positive which are connected together. That means this one becomes the source. So when you see from a diagram, if we have VR2 which is plus and minus, which now act as a source, we can have resistor 1 and the voltage source and the VR1. This is plus minus plus minus. So when we have plus and plus connected together, this normally becomes minus in such a way that we can say that the VR2 is equals to VR1 plus the voltage source. Now from this equation, we can see that this becomes the supply and this two behaves as a load. So when we have a 15 volts as a supply, we now have this 15 volts which will be divided into the 5 volts plus the 10 volts. So this equation normally describe the source and the load. So with the definition of KVL is meaning that the source that is applied must be equal to the load. So we can say source is equals to the sum of load in terms of the voltage. And when we put it in another way, we normally say that the voltage source plus the VR1 plus VR2 must be equals to 0. It is similar as bringing the VR2 to the other side of the equation, which now becomes Vs plus VR1 is equals to VR2. So VR2 is now acting as a source for this entire circuit. So in this video, we demonstrate the polarity which is important when dealing with a circuit. So you will come across a circuit theory in which you will analyze a circuit, and this becomes very important. And when we want to show it graphically, we can have, by using the operator, we can now, if we had, we have the Vs, which is equals to 10 volts. We can analyze for t equals to 10 seconds, and we can also have for t is equals to 10 seconds, we have VR1 which is equals to 5 volts, and we can have VR2 which is equals to, let's say, minus 15 volts. So remember that in this operation we are using the Kirchhoff voltage law, and the operation is addition, and t is equals to 10 seconds for the time. Now if we had this one and this region and this region, we all know that the voltage sum is equals to 0, and this graph is linear, meaning straight line. This is also linear, and this is also linear. So we use the expression 10 plus 5 minus 15, which will give us the voltage sum of 0. And remember that minus 15 is all about the polarity of the second connection. Mostly when we add this and add all of them together, they sum up to 0.